The last type of transformation we're going to talk about are exponential and logarithmic. These two are inverse functions of one another, which means that they're basically the opposites, I guess, in a way. So like when we do algebra, we do the opposite of multiplication is division. And so if something's being multiplied, you usually divide, and so on and so forth. Well, this is like the same idea. If something's being put to a power, if you take a logarithm of it, it will break it down so that you can, manipulate it a little bit better than you might have in the previously. And so with that being said, let's get into this. We can have the parent graph for this one be a lot of things. For instance, y is equal to 2 to the x. If you have y is equal to 2 to the x, you have a graph that looks something like the following. This is the point 0, 1. And then it's at 1, 2, and it just goes up exponentially. Now there's an asymptote here. There's an asymptote at y is equal to 0 in this case. And so there's no other asymptotes. The domain here is all real numbers because you can plug any value for x to any power as long as it's not like 1 over 0, which is not a number anyway. You will get the value. So if I give you y is equal to 2 to the x minus 2 plus 1, your asymptote here is going to fall at y is equal to k. Well, y is equal to 1 in this case. So if I draw the graph, it's going to go something like the following. This is 1, y is equal to 1. We have a shift horizontally of 2, so instead of it touching here at 0, 0, it's actually going to be lower than that. It's going to go something, 0, 1. It's going to do something like this. And that 0, 1 that was over here actually moved over here. And so I noticed it went through. So instead of it actually starting to come up right here, like it did here, it kind of stays flat there, and then it starts coming up a little bit later. So that's the only change. If you have negative versions, then obviously, let's use the same numbers, 2 and then plus 1. Then it would just be the same exact kind of thing going on, just going downwards. Okay. So these are your exponential ones, and h and k, they still shift. They do still shift. You can still use your formulas or your t-table and go x is 0. And then you'd go 2 to the 0 minus 2 plus 1. Well, that's 2 to the negative 2 plus 1, which is 1/4 plus 1, which is 1 1/4. And so this must be the point 1.25 or 1 1/4. If you put 2 to the 2 minus 2 plus 1, that's going to be 2 to the 0 plus 1, which is equal to 2. So this must be the 0.22. Okay. So you can do it this way, guys. I like I said though, I'm more concerned with you knowing the shape of it. If it's exponential, it should look like a ski slope, sort of like that. And then you can kind of go from there. With logarithms, let me point something out. The domain here, negative infinity to infinity. The range, it's wherever the asymptote starts. In this case, it's going to be 0 to infinity. It could be negative infinity to 0. It could be negative infinity to 1. It could be wherever the asymptote is to 1, or whatever the value is for the asymptote. With logarithms, it's a little bit different. These domain and range swap because they are inverse functions of each other if you have the right logarithm base. And so let's use base 2. So we have y is equal to log 2 x minus 2 plus, I don't know, we used 1 here. Let's use 1. In this case, the domain is going to be, it's an asymptote. It's going to be at x is equal to 2. So from 2 to infinity, Okay, so let me point that out. Asymptote. Over here, asymptote. In this case, y is equal to k. In this case, x is equal to h. So one's based on h, one's based on k. Obviously, it should work that way because x corresponds with h. So if you have values being shifted in the h direction, the domain should be limited by the h direction in that case. And then the range here, negative infinity to infinity. That won't change on logarithms and exponentials. Domain and range will not change. If it's logarithmic, negative infinity to infinity, that doesn't look like an infinity or a parentheses, so I'm going to fix it. And so if we tried this one, these ones look very similar. We go to x is 2, that's right here. And then these ones come down up from up here and go this way. They can also come down like this if it's negative and things like that. So, you know, pay attention to whatever a is. There's actually rules that go along with logarithms, which makes me worried a little bit, but I guess you'll find out in time. Not every example is going to be the same, but close enough. Make sure you guys practice this on Alex. There should be plenty of examples. I do know the following. If you go to my website, there is student practice for this one. So you can see the... is it in the notes? Yeah, I think it is. So if you go here, it says give formulas. That's what we've just done. And you can kind of look at these and you can see transformations. If x squared doesn't have any h value, it doesn't have any parentheses, it's probably h is just 0 in some of these cases. But are these compositions? What is this? I'm noticing g of f and h of f. I think I was just gonna do these as yeah. So for instance, 37. That says 3 minus x squared. That's h is 0, k is 3, a is -1, and so it's an upside down parabola in that case. So you just practice graphing some of these values. I would avoid the 43 through 45. Well, 43 through 44 I would avoid because those ones are a little bit more challenging, and we'll get into that in more detail later. 47 through 50, you guys can probably graph f and g. They're just transformations, that's why those are there. 51, 52, those are lines. 53 is a line. Actually, 56 is a line. Everything up to there is a line except for the x squareds. Those are parabolas. So give these a try, guys. Try to graph some of these and use Desmos to check your work. And I think you'll be fine. Thank you, guys.